Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on condensate modeling using PVTP software. And in previous videos, we have done the definition of pseudo properties as well as the separator train calculation. And we get relatively good result for first stage GOR and for the oil density for the second stage. Now we need to check the phase envelope. Okay, still in the calculation, we select phase envelope. Okay, we put it on the calculation window and then double click. All right, once the phase envelope object is placed on the window, double click, okay, to open the screen like this. And note that the object screens will open directly on top of the object icon, on top of the phase envelope icon, though we can still move it around like this. And as the equation of state, the fluid model within the pseudo properties has been, selected. Here, this green check mark, the phase envelope can simply be calculated. Okay, so that's why this calculate button active, and we just need to press this button and we can check the results. All right, so this is the phase envelope result. This is the calculated or the predicted phase envelope using our model, which is pseudo properties model. And this plus sign, green plus sign, is from the saturation pressure versus temperature based on lab data. And any relevant experimental data previously entered in the PVT sample object will automatically appear on plots, as can be seen like this data. This is based on this PVT sample. Okay. And as you can see, we have very poor agreement with the saturation pressure based on lab data, as there is over 2000 psi difference with this data point. Okay, the data point gives us 6,920 psig, whereas the predicted based on model only 4,685 psig for the saturation pressure. All right, and from these quality checks, we can conclude first, liquid density is realistic, but can be further tuned to reproduce the lab data. Okay, so we get, relatively speaking, good match for liquid density. And GOR is realistic, but can be further tuned to reproduce the lab data. And lastly, the saturation pressure requires further tuning to reproduce lab data because it gives us poor matching. Okay, and as the pseudo's physical properties are typically determined with a large margin of error, like more or less 10%, a match can be better achieved by changing the molecular weight, specific gravity, or boiling point temperature, okay, to get a better match, for example, for the saturation pressure. Okay, but for now, we will now focus on reproducing the liquid density and GOR first, while bearing in mind that the GOR carries the greater margin of error, because saturation pressure can be adjusted later, for example, through splitting of with the pseudo and introduction of binary interaction coefficient. So we now will focus on getting better match for density and GOR. And for the saturation pressure, we can match it later on by introducing binary interaction coefficient and splitting the pseudo properties, splitting the pseudo components. Okay. And yeah, that's it. That will be our strategy for the next videos. Okay. And the position of the critical point can also be adjusted, by the way, as a part of the regression, so that it can virtually be disregarded at this stage. Okay. And if you want to get a feel for how the molecular weight, the specific gravity, and then the boiling point boiling point temperature affect the separator and phase envelope calculation, we will want to change one parameter at a time, recalculate the pseudo properties that the object, and recalculate all the calculation objects. Yeah, that's it. You can change the molecular weight, rerun, and check the matching, or you can change the specific gravity, recalculate and check the quality of the matching, or you can change the boiling point temperature and recheck for the other calculation. Okay? And with this analysis complete, we will try to achieve as close a match as possible between the measured and calculated liquid phase density and GOR by changing the molecular weight and specific gravity only. So we will change the molecular weight and specific gravity only. For this, the following steps can be used. First, change a parameter in the pseudo properties, like change the molecular weight, and then press calculate to estimate the boiling point temperature and critical properties, while ensuring that the auto match options are selected to ensure that the calculated liquid phase density is realistic. Okay, and then we can just press calculate objects button here to recalculate all the calculation objects at once for quality checking. Like for example this. Let's say I want to change molecular weight from 205 to be just 200. I can recalculate, so I get this new boiling point temperature and new properties, and then I can recalculate. You see, my phase envelope changes. Let's say it's 250. Recalculate, and then recalculate this. I change again this phase envelope. Okay, and let's say specific gravity 0.85. Calculate, and then recalculate. It will change like this. So you can do trial and error like that. Change one parameter at a time, and then calculate, and then calculate for the phase envelope and saturator and separator train tests. Okay, but for now, if you want to follow me, let's go back to 205 and 0.82. Calculate and calculate objects. So we will start from this. Okay, so yeah, if you want to follow me, let's start again with this 205 and 0.82. Okay, and I think I'm going to stop here. So this video focuses on checking the phase envelope, which tells us that we have poor agreement for the phase envelope. Okay, in the next video, we will perform pseudo splitting. Until then, see you and thank you.